Geometry Chapter 9, Section 2, we're going to look at special right triangles today. And so there are two different ones we're going to look at. Let's go ahead and start with the 45, 45, 90. Okay, 45, 45, that adds up to be 90 degrees. Added up to the right angle, that's 180 degrees total. So this is a pretty good triangle here. Obviously, if these two base angles are the same, the 45s, then this is an isosceles triangle. And so these two sides have to be the same. Okay, so what I'm going to label them as is just label them as X. Since they're an unknown value right now, but we know they're both the same, then we label them both with X. And so the relationship of the hypotenuse, obviously it has to be bigger because the hypotenuse is the longest side. So what we do is we take whatever the side is and we multiply it by radical 2. Again, this is a special right triangle. It only works in 45, 45, 90s, which is what the entire section will be on. And so if I take a special right triangle, and I know it's a right triangle, and I know that this is 45, and then maybe they get crazy and they don't give you the other one, but you know it has to be 45 after adding them up and subtracting them from 180. And then they tell you that this side is 5, and this side is 5, but they want you to find this side, and since it's the hypotenuse, sorry, brain freeze, I'm going to go ahead and label it C. So they want you to find out what C equals. Well, over here, all we did was take what the side was, and we multiplied it by radical 2. So we know the sides this time are 5. So to find C, we take 5 times radical 2. That's it. We take the side that we know times radical 2. Now, will we always know the side? Of course not. So maybe this time they give us the hypotenuse of, let's say 7. And then they want us to find out what A and B are. Well, obviously they're the same things, so we only have to do one thing. So to go, if we were given the side, we would multiply by radical 2. If we're given the hypotenuse, okay, given the hypotenuse, we're going to divide by radical 2. So in this case, to find out what A and B are, I'm just going to do A. We're going to take the hypotenuse and divide by radical 2. Now, way back in Algebra 1, we learned that we can't have a radical on the bottom. So to get rid of that radical, we multiply numerator and denominator by that radical. 7 times radical 2 is 7 radical 2. Radical 2 times radical 2 is radical 4, or square root of 4, and we know the square root of 4 is 2. So we simplify that. So if the hypotenuse is 7, then the legs are 7 radical 2 over 2. And that is the 45, 45, 90 triangle. The next one is, I don't even know, I didn't even label that. That's awesome. That's the 45, 45, 90. Perfect. Now we're going to talk about the 30, 60, 90. And the 30, 60, 90 is a triangle up here that I use a lot. So this would be the 30. This would be the 60, and obviously the 90 is already labeled. And so in the 30, 60, 90, the easiest relationship is the smaller leg, which is here, that's our unknown, to the hypotenuse. The hypotenuse is 2 times as big as the smaller leg every time. And then the larger leg, I take the smaller leg and I multiply it by radical 3. Now, some people will get confused with the 45, 45, 90 and the 30, 60, 90 because one of them multiplies by radical 2, one of them multiplies by radical 3. The way I remember it is in the 45, 45, 90, you only have 2 different sides because those are equal. And so it's multiplied by radical 2, or 2 different angles, excuse me. In the 30, 60, 90 triangle, all 3 of the angles are different. So it multiplies by radical 3. That's just a little trick that I use. You're welcome to use that if you would like. So let's get an example, a little side by side here. And let's say, again, I'll go ahead and label these. That's the 60. I'll leave the other one off because, again, maybe they don't give them to you all the time. Let's say that the hypotenuse is 12. And so, again, if the hypotenuse is 12, it's 2 times as big as the smaller leg. So this has to be 6. And then the larger leg is the small leg times radical 3. Now, again, you can see some variations. Let's say that they gave us just the larger leg. So I've got, extend this just a little bit so I don't have to reach down. Let's say they gave us the larger leg, which was, let's say 12. Okay, so if we go from larger leg back to smaller leg, instead of multiplying by radical 3, we're going to divide by radical 3. That means we have to multiply top and bottom by radical 3. And we end up with 12 radical 3 over 3, which reduces to 4 radical 3. So the smaller leg is 4. Ooh, that's ugly. Sorry about that. I'll clean that up a little bit. Smaller leg is 4 radical 3. And then when I find the hypotenuse, I just double that. So 2 times 4 radical 3 is simply 8 radical 3. And so there shouldn't be any more variations than that. So that's special right triangles, the 45, 45, 90 and the 30, 60, 90.